Hi everyone, this is our last lesson on the unit and it's on reducing radicals. So before we get into radicals, we just want to do a quick review on what a perfect square is. Now if you recall, a perfect square is a number that results when a whole number is multiplied by itself. So a perfect square, and I've just listed a few in the chart on the right here. Perfect squares examples include 1, 4, 9, 16, 25, etc. Because, for example, number 9 is the result of the number integer 3, whole number 3, being multiplied by itself. A square root is a number that, when multiplied by itself, results in the desired quantity. So, for example, we know that 3 is the square root of 9 because 3 times 3 equals 9. When I use the term radical sign, all I'm referring to is the square root symbol. And it represents the process of taking the square root of a number. So this is just review, and we do expect you to know the perfect squares up to and including about 16 or 17. So if you want to review those, that would be great. So for example, we would expect you, without using a calculator, to know how to evaluate the square root of 49. So we know that root 49, and if we want to take the extra step, we know that that's just 7 times 7. So the square root of 49 is actually 7. We know that the square root of 100 is 10 because 10 times 10 equals 100. And if I were to take the square root of 9 squared, I can kind of see that a radical sign and a power of 2, they cancel each other out. So I know that the square root of 9 squared is actually 9 because 9 times 9 equals 9 squared. Before we get into the lesson as well, we need to recall this rule about multiplying radicals together, which I think you've seen before. So if I were to take the square root of a and multiply it by the square root of b, the result of that is the square root of a times b. So for example, square root of 3 times square root of 7, well, that's just the square root of 21 because that's the square root of 3 times 7. So just to review a couple of, definitions and rules that you might need to know. Next, we're going to take a quick look at the Pythagorean theorem, which you have definitely seen before. So if you take, for example, the right triangle that we have here on our right, what I just want to remind you of is that the longest side is called the hypotenuse. And the hypotenuse is always across from the 90-degree angle. It's also our longest side. Sometimes we call the other two sides, A and B, we call these the legs of a triangle, okay? And the two legs are always shorter than the hypotenuse. Sometimes the legs are equal length, but normally or more often one is longer than the other. So one way to remember Pythagorean theorem is that a squared plus b squared equals c squared, which we all know. Well, in this case, or in Pythagorean theorem, we have the legs on one side of the equal sign and the hypotenuse on the other side. So if I were to solve this question here where it says find the missing side, I know that this is one of the legs because this guy here is the hypotenuse. So I'm going to show you a common mistake. A common mistake is when guys think, oh, well, x is the one that has to go on one side of the equal sign, okay? And then they incorrectly sub in the 5 squared plus 13 squared on the other side. But as we said, that can't be true because the legs have to go on one side and the hypotenuse goes on the other. So the hypotenuse here is 13 squared, 5 squared plus x squared. So please don't make that mistake. You don't just automatically put the unknown on one side of the equal sign and the numbers on the other side. You have to make sure the legs are on one side. Okay, so if we evaluate this, I should know that 13 squared is 169 because I should have memorized that. I could also use my calculator, and that becomes 169 minus 25. So what's nice here is I know that 144 is a perfect square. So this means that x equals 12. If I take the square root of both sides, maybe actually I'll write that in. So the operation I just did was I took the square root of both sides. And the square root of 144 is 12. So that leads nicely into our next thing, which is the lesson of this unit. So this is new. I don't think you've seen this before. So if I asked you to take the square root of 49, that's pretty easy. That's just 7. But if I asked you to take the square root of 50, well, that's a decimal. So in this unit, when we ask you to reduce a radical, we don't actually want a decimal. I want to show you a way to reduce this radical so that it's still exact. So what I don't want you to do is tell me that root 50 is 7.0716, whatever this is, because it's inaccurate, it's rounded. What we want to do in this lesson is find an exact answer for this, okay? So what we need to do, what we need to look at is this relationship we've already seen, which is square root of a times square root of b is square root of a times b. And what we're actually going to do is use it backwards, okay? So I'm going to show you how. So the first thing we want to do is we want to write out all the factors of 50. So it says, write the number under the radical as the largest perfect square possible multiplied by another number. Well, what we need to do before we can do that is list out all the factors of 50. And I think I've got them all here. And then what we want to do is decide which one here is the largest perfect square possible. Well, when I look at this list, I actually only see 2 perfect squares. 1 is a perfect square and 25 is a perfect square. So 52, 5, and 10, they're not perfect squares. So what I want to do is write 50 as the largest perfect square multiplied by another number. Okay, so I can see that I'm going to write this as 25 times 2. Why am I doing this? Well, because I want to use this rule, this guy here, to help me split up the 50 into 2 radicals. So what I'm going to do is I'm going to write root 50 actually as root 25 times 2. And now what I can do is split it up. And if we've done this correctly, what we'll notice is one of these things is a square root of a perfect square. And I can actually evaluate this. So this is something we know. What is the square root of 25? Well, now I can write root 50 as, because I know the square root of 25, that's just 5. And this becomes this 5 times the square root of 2. And I don't have to write the multiplication symbol. Let me tell you one common mistake. Please don't make this one. A common mistake is guys sometimes tell me that root 25 equals root 5. They forget to remove the radical after they evaluated the operation. So please don't do this. Make sure anytime you take the square root of 25, for example, to be 5, that you're eliminating the radical. So let's do a couple of examples. These might seem obvious, but what can be helpful is writing out, a factor tree. So 1, 200, 2 times 100, 4 times 50, 5 times 40, and I believe 8 is our last one. Oh, 8, and then we probably have 10 and 20, and I think that's it. So in this list, we can see a number of perfect squares, right? 1, 100, 4, 25. Okay, but remember, we said we always want the largest perfect square. So the largest perfect square corresponds to these 2. Okay, so I'm going to rewrite root 200 as root 2 times 100, times root 100, sorry. But now what I want to advise you guys to do is I'm going to flip these around because I always want the perfect square to go first. And the reason is because I know I'm going to evaluate this 100, that evaluates to 10. And normally, like had we left it the other way, we would have gotten root 2 times 10, and that looks weird. Okay, we usually put the radical at the end. Okay, and the whole number first. So square root of 200 is 10 times root 2. All right, let's do this again for 162. 162 divided by 2 is 81, and I'll just stop us there. That is going to be the largest perfect square that we get here. So I'm going to rewrite this as root 81 times root 2, and I know that root 81 is 9, and I have reduced the radical. And notice that these answers are exact answers. If I had just put in root 162, I would get 12.727 and a non-terminating decimal. And what you'll notice is that 9 root 2 is exactly root 162. So we're looking for exact answers here. So please do not use decimals.